So the mean, the median, and the mode lie here. The normal curve divide the mean, median, and mode divide the circle into two congruent parts. We also said that the area under the normal curve is 1 or 100%. In other words, 100 divided by 2, 100%, divided by 2 is 50%. Okay, so the right side of mean is 50%, the left side of mean is 50%. The total area that lies under the normal curve is 100. So we said that. So these are the properties. We are reviewing the properties. One of the properties here that is not mentioned here is that the normal curve uses empirical rule. So we talked about empirical rule last class. We talked about empirical rule last class. So today we are going to discuss z-score. How do we use, how does normal curve use z-score? All right, so there is a normal curve with a smaller standard deviation. So this is a normal curve here. So you see, normal curve with different mean, same standard deviation. This is how they look. And normal curve with a smaller standard deviation narrows up like this. If a normal curve has a large standard deviation, it's flatter. So this has a larger standard deviation, and the mean is smaller. The mean here is larger. The mean here is 21, but a narrow normal curve indicates that the standard deviation is small. In other words, they are just clustered together. They don't have a lot of difference between them. Okay, so let's look at the next PowerPoint. So this is still the empirical rule we talked about, except that this is a different diagram. So we talked about empirical rule. 68% of data lie within one standard deviation. Note that from here to here is 68%. From here to here is 95%. From here to there is 99.7%. And it lies within 3 standard deviations. So we talked about them already. So let's go back to now. Suppose we are given a raw data like we have before. How do we calculate the area under the normal curve? We did it again the other day, but I can just get my calculator and find the area under the normal curve within one standard deviation. So we see, if we still remember, what is the area under the normal curve within one standard deviation? We are told that the mean is 4.2 and the standard deviation is 0.3. So we will later on convert this to a standard normal. If you standardize a normal curve, it becomes a standard normal. So today we are going to actually see how to use z-score to standardize each value given to us as a normal curve. Okay, so again, we have done this, but let's emphasize the fact that area under the normal curve within one standard deviation is 68%. So that is what they just said here. So I'm going to actually pull out my calculator again. I usually make sure I say this twice because I want to make sure that every student can get that. or maybe if you come back, if you didn't come to class. So this is the diagram here. And then we want to do it again, find the area between two standard deviations. We're given that the standard deviation is 0.3. All right, so we did it before just to refresh our memory before we go to z-score. Okay, so the z-score will be what we'll talk about later on. So this time I brought another normal curve. It's still a normal curve. There are so many different normal curves. If it is not standardized, we call it normal curve. It is not a standard normal curve. This is not a standard normal curve because I still have raw data here. So this is ordinary normal curve. This is an ordinary normal curve because it's not standardized. All right, but when I finish standardizing, see, if I standardize the mean, and I'll quickly standardize that now, I am going to get my calculator, or I can just do it by hand and standardize. You see, we have the standard deviation is 0.3. And so the mean is 4.2. So what I'm going to do is try and see if my whiteboard will actually do this quickly. So I am going to use my whiteboard to standardize. I'm going to clean this and just wipe that out. I am trying to. Okay, so I'm going to clean what is here using my eraser. Erase this and actually write the right date here. This is not the right date, but this is not for this class, but I want to, so, and take that off entirely. All right, so I want to maybe grab that and get it off my way so I can do, okay. All right, so what I want to do is go back to that diagram. All right, go back to that diagram and standardize. So what is the formula though? What is the formula for z-score? I already said there are properties of normal curve. The first one was empirical rule. We talked about empirical rule the other day. Now, let me see if anybody joins so we can say good afternoon. All right, let's see. Book. This is actually not a current book, but I like the way this book decorated it. Um, so it doesn't really matter what's the raw data. This is still raw data. And so we shall call this one normal curve. We cannot call it standardized normal because it's not standardized yet. But if you calculate like we did the other day, you get your calculator. You put in lower bound, upper bound. Remember what we did the other day. So if I'm trying to find the area under the normal curve, the empirical rule already told me, if I have to memorize it, this is 68%. Okay. All right. So we used that calculator and we checked it. This is 95%. And this is 99.7. I want you to know that the mean is 4.2. 4.2 plus 0.3 is 4.5. One standard deviation above the mean. 4.2 plus 2 times 0.3 will give me 4.8, and so on. Okay, so quickly I am going to actually draw this normal curve. And actually before we will actually standardize this. So I'm going to draw a line there. And I'm going to go to my, I'm going to get my whiteboard and pull it this side. pull it on this side. Okay. Hopefully it's going to behave. Okay. And then I want to use this score to standardize. I want to standardize this raw data, even though it's normal curve, but it's a raw data, so it's just normal curve. When I finish standardizing it, I'll call it standard normal. I always try to emphasize this in class because if you're told to convert from a normal curve to standard normal, you are told to find the z-score of the raw data and transform it to a standard normal. So that's what I'm going to do now. I'm going to transform this one to standard normal. This one right here, this is already a normal curve. It's not a standard normal because the numbers are not standardized. Okay, so I hope it makes sense what I'm trying to do. Okay, so I don't want to use calculator now. That way it will not look. So by the way, what is the formula for z-score? The formula for z-score, that's why I pulled this. The formula for z-score is z equal to score. I mean, whatever. Let me call the value. So that value minus the mean divided by standard deviation. So this is the formula for standard deviation. I'm just going to write deviation here, the IV there. Okay, so I want to change this value to x. So z is equal to x. And I want to assume that we are using population. So I write population mean. And since it's a population, the standard deviation will be sigma. Okay, let me make sure I write it so you know that a sample can be normally distributed. So suppose a sample is normally distributed. I'm going to change this date to 9/9/24. Oh, so suppose I'm working on a sample, then the formula becomes z equal to value minus x bar. You must know the difference. All over s of x. Why? Because I am finding the z-score of a data that is normally distributed from a sample. So I'm going to use statistic. X bar and standard deviation S of x is a statistic. This statistic is a statistic. If I'm given a population, if I'm told or I know that the data is a population, then I will use parameters. So the mean mu is a parameter. Sigma here is a parameter. So you have to make sure you know which one you're doing. Of course, the data will say it's a sample. The sample can be normally distributed. So by the way, let's assume that the data we are using right here is a parameter. So that I'm going to be using this one here. Okay, so I'm going to minimize my, okay, so that way I'm going to minimize it. So now I have written the formula. Let's go back. Let's actually standardize. So I'm going to standardize. So remember that the normal curve is value z-score, or z is value minus mean mu over standard deviation. Okay, what is the mean? I already know they gave me the mean. Even if they didn't give me, the mean is always at the line of symmetry. The mean is always at the line of symmetry. So I know the mean already. So z-score of mean, I'm finding the z-score of mean, which means the mean is the value. Come on, stop. So 4.2 minus 4.2 divided by standard deviation, which is 0.3. Okay, 4.2 minus 4.2 is 0. Since the numerator is 0, the z-score of the mean is 0, right here. Okay, one standard deviation above the mean, even though we know it's going to be 1, but let's standardize it. So let's standardize it. I'm just going to do this so that you know how to standardize. Yeah. So when you see z-score, find the z-score of this in a test, you will know how to find simplify it. All right. So I am going to clean this. Well, not right, not really. So I'm just going to leave it and get my body again. This time I want to standardize 4.5. In other words, one standard deviation above the mean. So I'm going to just do this. If you don't mind, I'm going to clean this that way. So I'm going to clean this up that way. It's less. Get that. Okay, now I want to find the z-score of the 4.5. So I'll put in the argument. So the argument says that z-score is equal to value. Value this time is 4.5. 4.5 minus mean. The mean is 4.2 over standard deviation, which is 0.3. Then I simplify. So z-score of 4.5 is equal to 4.5 minus 4.2. I have 0.3 over 0.3. So 0.3 over 0.3 gives me 1. So what does 1 mean? It means 1 means that 4.5 is one standard deviation above the mean. So I'll put 1 here. Then, you know what? I am going to actually assume this. 4.2 plus 2 standard deviations. Two standard deviations will be 4.2 plus 0.6. And that's 4.8 here. So, well, let me actually find that this z-score again. So I'm going to do the z-score again. All right, so this time it is a z-score of 4.8. So z, by the way, this is in chapter 3. So it's in PowerPoint 3. So it is going to be value, and value this time is 4.8. 4.8 minus mean again, divided by standard deviation. 4.8 minus 4.2 is 0.6. After all, what did I add? 2 standard deviations. When I divide by 0.3, I got 2 standard deviations. So this gives me 2. This is another way of saying that 4.8 is 2 standard deviations above the mean. All right, so let's take a number that is on the left-hand side. We already know what this one is going to be, but I have to standardize it. So let's standardize that. What are we doing? We are working on another property of normal distribution, or bell-shaped distribution. The other day we worked on empirical rule, very important. This is the beginning of statistics. And we do it in chapter 3, unit 1. Actually, we are going to do it again, but more in depth in chapter 7. But you have to start from chapter 3 to know what we're talking about. Of course, z-score is in the test. The empirical rule is in the test also. Okay, so I'm going to clean, and then I'm going to take a number that is on the left-hand side of the mean and see how it looks. So I'm going to find the z-score of a number on the left-hand side of the mean. So z-score is still going to have the same formula. So value minus mean Remember, we are looking for the mean of a parameter. In other words, it is a population. Stop. All right. And standard deviation is, okay, so I'm going to put a number. By the way, what number am I putting in? I'm going to move this a little bit so you see what the number. One standard deviation below the mean is 4.2 minus 0.3. So I have value 3.9 minus mean 4.2 divided by 0.3. If I look at the numerator, 3.9 is smaller than the mean. So 3.9 minus 4.2 is negative. So minus 0.3 divided by 0.3. All right, so this is 1, negative 1. So what does it mean? If a number is on the left-hand side of the mean, it has a negative. So z can be negative. Very soon we shall start calling it z. It's one standard deviation below the mean. If another number here, of course, you know, I will not be going. 3.6 is going to be 2 standard deviations below the mean, so it's going to be negative again. 3.3 will be 3 standard deviations below the mean. And if I work on 5 here, 5.1, I have 3 standard deviations above the mean. So if a number is lower than the mean, then it will have a negative z-score, which means if I have a negative z-score, that implies that that number is below the mean. Anyway, I was trying to make sure you know the difference. I just want to make sure before we get to chapter 7, you want to know the difference between a normal distribution and a standard normal distribution. This one right here with our beautiful colors is a normal distribution because even though it's bell-shaped, it still have given data, raw data. It is not standardized yet. But this one right here is a standard normal distribution. Why? Because we have standardized the scores. You already see that the mean is 0. Of course, the mean is going to be 0 all the time. Whenever you standardize the mean will be 0. Okay, and now you have, so this is a standard normal curve. You can read in the chart to find the area between, and you know, even if it's a standard normal curve, if you use the chart, you read the chart. I say we're going to read the chart today, but if we cannot, we can wait because we are going to do normal distribution again in unit 3. Important thing is to know the basics, know how to find z-score. You don't really need to. I don't think you need to read the chart now, but if you have time, we can read the chart. I have the chart here. I'm going to put it in Blackboard. That way you have the chart. Okay. Now I am going to get another. Let me get another one. All right. So this is what I've been talking about, though. Even though so the standard score or z-score represents the number of standard deviations, a random number x. I want to make sure we know that this random number is called value. A random number x minus mean, and so on. This is the formula for standard score. Okay, so they gave us an example to do. So let's do this example, or let's watch the example. Because we have done one, let's watch this is not a book, or this is not the, but you know, it's very easy here. I like to get PowerPoints, borrow PowerPoints. This is a notebook I use in another school, but I like the example. If I like the example, I'll bring it here. But anyway, the important thing is the test scores. The test scores for a civil service exam are normally distributed with a mean of This is the mean of that test score. Whenever you're given a mean and a standard deviation, you can be told to find the z-score. Find the standard z-score for a person with a score. So they give you everything they need to give you. So they want you to standardize the score for someone who scored 161. So this is the score of that person. This is the mean, and this is the standard deviation. So the person's score minus mean divided by standard deviation, and the answer you have is called standardized score. So now, when you finish standardizing it, no number should be greater than 1. In other words, the range of z starts from -1 is less than z is less than or equal to, less than or equal to 1. If numbers, and by the way, z can be 2 point something. I'm trying to say a standard score can be 2 point something, but I'm trying to say that when you finish in standard score, you will have numbers that are small. So actually, I will take this off because that doesn't, let me take this off. Okay, so when you finish standardize, also they've told us to find the standard score of someone who has 148. 148 minus mean divided by standard deviation, and so on. So that is how to standardize. Anytime you standardize the scores of a normal distribution, you have changed the normal distribution to standard normal distribution. Okay, and now when you finish changing it, you can now calculate again. So what we did, we're going to do what we did the other day, but today we have standard normal. So I'm going to pull up my calculator. I am going to pull up my calculator and find the area between -1 standard deviation and 1 standard deviation. Of course, the empirical rule says that the area between them is 68%. So we want to, because our calculator knows whether it's standardized or not, it's still going to give you the correct answer. So whether it's raw score, you get the area, the equal area, 68 approximately. So I'm going to use my calculator this time, normal CDF, and I'm going to use the standard scores. What I'm trying to emphasize is you can use standard scores in your calculator and it will calculate your answer correctly, or you can use raw scores. It is easier. That's why it is easier to use your calculator, because if you have 20 questions in a test and you have 90 minutes, you want to minimize time that you're wasting on, well, not wasting, using on one question, because you don't want to be in a situation where you did not finish the test. You are going to be told to attempt all questions. And you have to, if you attempt all questions, the chances of you doing very well is very high. But let's say you were just doing the standard score by hand and you get to finish only 15. Well, you minimize the number of the chances of getting a high score. Okay, so remember the argument the other day. Normal. See, if I am using normal CDF, I am used lower bound. Let me start lower bound, upper bound, mean, standard deviation. That is the argument. So when I pull my calculator up, that's what I'm going to write. But the difference today is that the data is standardized. The difference is that the standard I'm trying to find the area of is standardized. By the way, where did we go the other day? I always repeat this. Second distribution. What am I looking for? Normal CDF. Do not make the mistake of putting normal PDF. And by the way, PDF means probability density function. Normal CDF means cumulative density function. So cumulative density function means you're looking for area. And this time we're looking for area between, so I'm taking number 2. So I'm looking for area between one standard deviation. One standard deviation to the left, so -1 to +1. So you see lower bound is -1. Upper bound is 1. The mean is standardized. Therefore, mean of a standardized normal is 0. The standard deviation of a standardized normal is 1. Because you're moving up and down, one standard deviation above or one standard deviation below. I hope this is clear. Your calculator can calculate area under the normal curve even when you're using a raw score or you're using a standard score. Okay, so I'm going to calculate, and then now it's going to give me an argument. It's asking me, is that what you intend to calculate? I say yes. I'm saying yes. Do you want to calculate the area between -1 and 1 in a standard normal curve? Of course, your calculator understands that whenever the mean is 0, it's a standard normal curve. Your calculator understands that whenever the mean is 0 and standard deviation is 1, it's a standard normal curve. Okay, if I hit enter, it is almost the same as empirical rule. It's exactly the same as the calculation we made the other day. So it doesn't really matter whether you have raw scores or standard scores, your calculator knows how to do it. Okay, that's why TI-84 is a requirement in this class. All right, so let's verify area between two standard deviations. I can quickly just do second enter. In other words, I brought down the first one. I'm only going to change -1 to 2 and also change 1 to 2. So area between two standard deviations. Okay, and when I hit enter, I get something. Okay, so let me go back and bring it down. So I know that it is going to be, okay, I see what is going on. The standard deviation is supposed to be 1. The upper bound is 2. Sorry for that. All right. So I'm asking my calculator, can you give me the area under the normal curve when the lower bound is -2, the upper bound is 2, the mean is 0, and the standard deviation is 1. And so you see that my calculator knows now that this is a standard normal. Because whenever I say that the mean is 0, it knows it's a standard normal area under a standard normal curve. Okay, I hit enter. And it tells me that the area between -2 to 2 standard deviations is 95.45. Okay, I have already told you before that your calculator is more accurate. You really want to use your calculator because it's more accurate. Okay, you see, empirical rule says 95%. But anyway, empirical rule said approximately 95%. Okay. All right. So the same thing, if I check from area to the left, -3 to 3 is going to be the same. We don't have to check that, but we already know that empirical rule, my calculator, in fact, my chart, when we start reading the chart, my chart, they are going to be the same. Okay. And